Engineers are panicking. The same killer engine that destroyed Flight 8 just struck Flight 10. Ship 37 emergency removal from the pad has everyone asking, is SpaceX hiding a fatal design flaw? 600 Raptor engines built, yet vacuum engines keep exploding in the same exact way. Flight 7, 8, 9, all killed by identical failures. But here's what's really shocking. Why does SpaceX keep using engines they know will fail? What aren't they telling us about Starship's biggest weakness? Let's dive right in. Picture this. August 1st, 4:30 p.m. Ship 37 has just completed what engineers called the most beautiful static fire we've ever seen. 6 Raptor engines roaring to life in perfect harmony. Every telemetry reading green, champagne bottles popping in mission control. 48 hours later, emergency crews are ripping that same perfect engine out of the ship. What they found inside will haunt SpaceX for years. The vacuum Raptor showed signs of the exact same microfractures that killed Flight 8. Same location, same failure signature, same death sentence. But here's the part that'll make your blood run cold. SpaceX has known about this pattern for months. Let me show you something SpaceX never wanted you to see. NASA cameras just captured heavily damaged Raptor engines arriving at SpaceX's McGregor facility on flatbed trucks. These weren't just any engines. These were the mangled remains from Ship 36's spectacular explosion earlier this year. The timing is perfect. Ship 36 explodes. Ship 37 develops identical problems. Coincidence? Not a chance. But wait, it gets worse. Raptor engine serial number 580 was spotted at McGregor. That's the highest V2 serial number ever seen publicly, meaning SpaceX has built close to 600 Raptor 5.2 engines. 600 engines. Same failure mode. Every single time. You want to know why vacuum Raptors keep exploding? It's not what the textbooks tell you. These engines operate at 300 bar of pressure. That's 4,351 pounds per square inch crushing down on every component. To put that in perspective, that's like having a full-grown elephant standing on every square inch of the engine. But pressure isn't the killer. Temperature is. Inside those vacuum engine bells, temperatures reach 3,000 degrees Celsius, hot enough to melt copper in milliseconds. The engine has to pump liquid methane at negative 162 degrees Celsius through turbopumps while combustion chambers burn at temperatures that would vaporize steel. It's like trying to keep an ice cube frozen while holding it inside a blast furnace. Here's what SpaceX engineers whisper about in the cafeteria. The vacuum Raptor design is fundamentally flawed. Remember those bird's nest of wires and cables we saw in early Raptors? Those weren't just for show. Each wire was a sensor, desperately trying to monitor temperatures and pressures that shouldn't exist in nature. SpaceX has been at war with these sensors since day one. They recently lost a Falcon 9, their first failure in over 300 launches, because of a loose sensor line. One wire brought down their most reliable rocket. Now imagine 33 engines, each with hundreds of sensors, all trying to survive conditions that would make the surface of Venus look comfortable. But Ship 37's perfect static fire wasn't perfect at all. It was a carefully orchestrated lie. Here's what really happened. During the 6-engine test, telemetry showed micro vibrations in Raptor vacuum engine number 4. Not enough to abort the test, but enough to plant seeds of doubt in engineers' minds. Post-fire analysis revealed hairline cracks in the engine bell, the exact same cracks that have plagued every vacuum Raptor since Flight 7. SpaceX tried to convince themselves it was within acceptable parameters. It wasn't. 72 hours later, those hairline cracks had spread like cancer through the engine's superstructure. The replacement wasn't preventive maintenance. It was emergency surgery on a patient that was already dying. While Ship 37 bleeds on the operating table, the entire Starship program hemorrhages credibility. Booster 16 sits perfectly ready in the rocket garden. $50 million worth of flight-ready hardware waiting for a partner that keeps breaking down. Every day of delay costs SpaceX $2 million in operational expenses and pushes NASA's Artemis timeline further into the void. But the real catastrophe isn't financial, it's systematic. SpaceX just moved their test infrastructure for the fourth time in 6 months. The orbital launch mount has been reconfigured so many times that engineers joke about needing GPS to find the bathroom. Every engine swap triggers a complete rebuild, test stand removal and reinstallation, 20 bolt-on adapters repositioned, dozens of propellant feed lines reconnected, flexible hoses recalibrated, hold-down clamps removed and replaced. It's like performing heart surgery on a patient while the operating room is being demolished and rebuilt around you. Here's the secret SpaceX doesn't want you to know. They're abandoning the V2 architecture entirely. While Ship 37 struggles with its dying V2 engines, multiple Raptor V3 prototypes have been secretly undergoing testing at McGregor. The V3 isn't an upgrade. It's a complete admission that V2 was a dead end. Look at this image. Describes the skeletal V3 engine. This doesn't look like an evolution. It looks like SpaceX threw out everything they thought they knew about rocket engines and started over. But here's the terrifying gamble. V3 engines aren't ready for Flight 10. SpaceX faces an impossible choice. Delay Flight 10 indefinitely until V3 is ready, or launch with V2 engines they know will probably fail. The August 22nd target date isn't optimistic scheduling. It's Russian roulette with a rocket engine. Remember that routine rebuilding at the Massey test site? It's not routine at all. SpaceX isn't just replacing destroyed equipment. They're building military-grade protection systems. The original above-ground propellant lines have been completely abandoned in favor of underground trenches reinforced with steel rebar. Why go underground? What kind of explosions are they expecting that require buried, bunker-protected infrastructure? A reinforced concrete bunker is being constructed adjacent to the trenches, not for routine operations, but for instrumentation and valves. That's the kind of protection you build when you expect your test facility to regularly explode. Flight 7, engine failure, vehicle lost. Flight 8, engine failure, vehicle lost. Flight 9, engine near failure, barely survived. Flight 10, engine replacement, outcome unknown. This isn't bad luck. This is systematic failure of a design that SpaceX rushed into production before it was ready. But there's a darker pattern hiding beneath the surface. Every single vacuum Raptor failure has occurred in the same sequence. Micro vibrations during static fire, ignored. Hairline cracks in post-fire inspection, deemed acceptable. Catastrophic failure during flight, predictable. SpaceX has had the data to predict these failures for months. They keep flying anyway. Ship 37 will return to the orbital launch mount within 48 hours for its replacement engine test. This isn't just another static fire. It's SpaceX's last chance to prove they can break the failure cycle that's haunted every recent flight. If the replacement engine shows even the slightest anomaly, Flight 10 gets pushed back weeks or months. If it passes, SpaceX still faces the ultimate question. Will this engine suffer the same mysterious failures during flight? The payload bay awaits its dummy Starlink satellites. $10 million worth of test hardware that will either validate SpaceX's deployment system or become the most expensive fireworks display in history. But the real test isn't the engine. It's whether SpaceX has finally learned from their mistakes, or if Flight 10 will become the fourth consecutive mission to fall victim to Vacuum Raptor curse. August 22nd represents more than just a launch date. It's the moment when SpaceX's credibility either survives or dies. 3 consecutive flights with vacuum engine problems, a test program that's consumed hundreds of millions of dollars, a NASA partnership that depends on Starship actually working, congressional hearings waiting in the wings if another flight fails. And at the center of it all, one replacement vacuum engine that might or might not break the deadly pattern that's haunted every recent Starship flight. The clock is ticking, the engine is installed, the world is watching. Will Flight 10 finally break the curse, or will SpaceX's Vacuum Raptor problem claim another victim? So there you have it, SpaceX's most ambitious mission hanging by a thread, because of an engine they've built 600 times but still can't perfect. The August 22nd launch isn't just about reaching space. It's about whether humanity's path to Mars survives this engineering nightmare. Every Vacuum Raptor failure pushes our multiplanetary future further away. But here's what really keeps me up at night. If SpaceX, the company that lands rockets on floating platforms, can't solve this problem, what does that say about the impossible challenges waiting for us on Mars? We'll be tracking every static fire, every engine swap, every hint of whether Flight 10 breaks the pattern. Because when that countdown reaches zero, we're not just watching a rocket launch. We're watching the future of human spaceflight hang in the balance. What do you think? Is SpaceX's vacuum Raptor curse fixable? Or are we witnessing the limits of current rocket technology? Drop your predictions below and hit that subscribe button because Flight 10's story is just beginning. Jeff Bezos' $10 billion Kuiper is dying. ULA just shocked everyone by failing spectacularly. 70 missions backed up, rockets breaking down mid-launch. Amazon deliberately snubbed SpaceX, but now they're secretly begging Elon for help. The leaked truth? Bezos might lose everything to the FCC deadline, but wait until you hear what SpaceX is demanding in return. Let's dive right in. Here's what nobody wants to admit. SpaceX has already won the space race, and they're making everyone else pay for it. While Amazon burns through $10 billion, SpaceX launches every 2.7 days like it's routine. But this isn't just about reliability. This is about SpaceX turning rocket science into rocket manufacturing. Think about this. ULA takes months to prepare a single launch. SpaceX ? They launched 96 times last year. That's not twice as good. That's a completely different universe of capability. But here's the twisted part. Amazon knew this. They had the data, yet they still chose to bet against the house. Picture this scene. June 16th, Cape Canaveral. Amazon's second Kuiper launch sits on the pad, ready to prove ULA can deliver. Weather clears. Countdown begins. Then, engineering failure. Gaseous nitrogen purge line overheating. ULA's CEO Tory Bruno announces they need more evaluation. Industry translation? We have no idea what went wrong. But while ULA engineers scratch their heads, SpaceX launched 3 more missions that same week. 3 more missions. This is when Amazon executives started having their late-night panic meetings because the math was becoming undeniable. ULA's success rate? Maybe 85% on schedule. SpaceX ? They're hitting 99.43% success with ridiculous frequency. The brutal truth? Amazon needs 35 to 40 launches per year to meet their deadline. ULA can deliver maybe 5 to 8 if everything goes perfectly. The gap isn't just big, it's mathematically impossible to close. But surely Ariane 6 could save the day? This is where the story gets almost comical. Ariane 6 has flown exactly twice. Twice! Amazon is betting half their constellation on a rocket that's still figuring out how to reach orbit consistently. The European Space Agency promised Amazon the moon, but they can barely manage low Earth orbit on schedule. Here's the insider secret. European contractors are privately panicking. One unnamed executive reportedly told colleagues, "We sold Amazon a dream, but we're delivering a nightmare. The manufacturing lines are still broken from years of delays. Supply chains are fragmented across multiple countries. They're promising 6 Kuiper launches per year when they can barely manage 5 total launches annually." Amazon executives are watching their European partners flounder while SpaceX launches more rockets in a month than Ariane 6 has flown in its entire existence. Now here's where this gets personal for Bezos. His own rocket company, the one he's poured billions into, can't even help save his satellite project. New Glenn was supposed to be operational years ago. Instead, it's sitting on the ground while SpaceX racks up launch after launch. Imagine the boardroom conversations. Bezos probably asked his Blue Origin team, "Why can't we do what SpaceX does?" The answer, because SpaceX didn't just build a rocket. They built a rocket factory. While Blue Origin perfected their engines in isolation, SpaceX was iterating, failing, learning, and scaling at industrial speed. Blue Origin employees are reportedly demoralized. They've watched SpaceX achieve in months what they've been trying to do for years. Some engineers have quietly started interviewing at other companies. The ultimate irony? Bezos owns the company that should be saving his satellite constellation, but it's the one provider that definitely can't help him. Here's what makes SpaceX's dominance so devastating. They've turned rocket launches into something that looks almost boring. Every 2.7 days, another Falcon 9 mission. Perfect landing, perfect deployment. Rinse and repeat. They've made the impossible look routine. ULA celebrates when their rocket doesn't explode. SpaceX gets annoyed when landing isn't perfectly centered. But the real kicker? Cost. Falcon 9 launches cost $62 million. ULA's Vulcan? $110 million. SpaceX isn't just faster and more reliable. They're literally half the price. Amazon is paying premium prices for inferior service while watching their competitor launch superior rockets for less money. It's like buying a horse-drawn carriage while Tesla offers free rides. But here's what industry insiders don't want you to know. SpaceX's real advantage isn't their engines or their landing technology, it's their manufacturing philosophy. While ULA handcrafts each rocket like a luxury car, SpaceX builds them like Toyota builds Corollas. Mass production, quality control, rapid iteration. They've applied automotive manufacturing principles to rocket science. Elon Musk's secret sauce? The best part is no part. The best process is no process. SpaceX's Raptor 3 engine looks like a skeleton compared to previous versions. They've removed thousands of components, integrated everything through 3D printing, and created engines that are simultaneously more powerful and simpler to build. ULA is still welding rockets together piece by piece. SpaceX is 3D printing integrated engine components that would take ULA months to assemble. But here's the leaked truth that's sending shockwaves through the industry. When Amazon quietly approached SpaceX for additional launches, the negotiations took a dramatic turn. SpaceX didn't just quote higher prices, they demanded something unprecedented. Brand new Falcon 9 boosters for every